Hello, everyone. Welcome to this session on how platform engineering teams can augment DevOps with AI. My name is Manjunath, and I'm a research analyst in Gartner's software engineering practice. We've all seen this play out multiple times. The business stakeholders come to us and say, AI is a game changer. Can we double our developer productivity or deploy perhaps at twice the velocity? And we, as software engineering leaders, are scratching our heads and going, why are we not seeing the promised benefits of AI? And this is exactly where platform engineering plays a role. We believe there are fundamentally three approaches to augmenting DevOps with AI. The first is all about improving developer experience. That's focused on the experience that developers have during development, during deployment, and so on. Secondly, we focus on enhancing software delivery efficiency. That's all about improving CI/CD workflows, things like, for instance, test impact analysis, and so on. But last but not the least, it's also about optimizing software delivery infrastructure. Because remember, infrastructure and operations is an integral part of DevOps. But guess what's missed out in all of these steps? You guessed it right. It's a pre work step. And the pre work is all about identifying and prioritizing where the real constraints lie. And constraint, let's define it as simply as something that limits the system from achieving higher performance. Right? So if you think about what precisely those pre-work steps might involve and how might we identify those constraints and prioritize those constraints, there are two kinds of constraints if you think about it. The first is what you're seeing on your screen right here, which is as work items move through the SDLC and work flows across multiple phases of the SDLC, you'll find that there are constraints that surface in numerous ways. For instance, you might think of a constraint as developers having to wait on product owners or developers waiting on designers, for instance. That's a constraint. You could have other types of constraints where developers are waiting on security approvals and compliance approvals just before deployment, or operations teams might be taking on pre-production checklists. They might be going through a verification process. Now if you think about all of these, some of these constraints may be value adding, but a lot of these could be non-value adding kind of constraints. But regardless of the type of constraints, these constraints which introduce delays don't necessarily translate into customer value, and customers don't see that value in terms of they don't necessarily see, even if it's a value added process that's taking time, they don't necessarily see the value from their perspective. So if you think about identifying these constraints, we got to map the complete life cycle all the way from where a request comes in to when we deploy stuff to production. Unless we have this complete systemic view of how work items flow through our software delivery work stream, we wouldn't be able to necessarily pinpoint where is it that AI will truly add value in the software development lifecycle. So this is a very essential and a critical part of augmenting DevOps with AI. Literally, like the very first step is mapping out your complete software delivery value stream and understanding where the real constraint lie. Because if you think about it, just focusing on the create aspects of DevOps, if your real bottlenecks lie elsewhere, is not going to give you the promised benefits of AI augmentation. The second kind of constraints is much easier to fathom, which is these constraints lie within what we call a single logical thread of work. So for instance, it's not like in the previous step we saw where you find these constraints as work items move from one phase to another. These constraints that you see here lie within a single phase. For instance, think of an inner development loop that involves a developer coding, testing, just refactoring, and then the classic inner loop before they commit code into source code. Right? If you think about where the greatest constraints lies in just this phase, it might be not necessarily coding, but it could also be about debugging. Right? So debug or troubleshooting issues as they're coding, that could pose a real constraint within a specific phase. Or let's say if you're in planning, your constraint could be in threat modeling, which we often know that threat modeling is not performed at all in many companies, because because of the very fact that it poses a lot of constraint, it causes delays, and people tend to skip it. And so if you think about what kind of constraints could benefit from AI augmentation, it could be practices like threat modeling, which improves a single phase. It could be, for instance, AI augmentation to improve developers' ability to troubleshoot issue. Or if you think about in operation space, at the very fag end, you might think of constraints like, for instance, root cause analysis, or speeding up developers' ability to analyze logs, right? So in general, doing a pre-work exercise increases our ability to obtain the ROI on AI augmentation, not just in one phase, but across all of these phases. And the whole idea now is, if we look at AI augmentation, it's what we're really trying to achieve is not about improving or achieving a certain set of productivity improvements within a single phase, but how can we translate those benefits across the complete SDLC lifecycle, so customers see the true value of AI augmentation. So this talk will primarily be focused on how do we take a look at the systemic view across the full SDLC. It's not a narrow focus on a single phase of the SDLC. So let's first focus on improving developer experience. Now, developer experience, as most people might perceive, it's not just about improving developers' inner loop, right? So, well, it could very well be code completion, which is typically what is considered as improving developer experience. But there's also things like, for instance, summarizing your pull request changes, like I have underlined here. And summarizing pull request changes helps improve the experience of peer reviewers. Now, if you submit a pull request and it's a large request, let's admit it, many times you have very large pull requests that you submit involving tons of files across multiple directories. It's very difficult for a peer reviewer to understand what might be the implication of this change. So one way to use AI augmentation is automatically summarizing the content of your pull request. Another aspect of developer experience would be if you can prioritize your test runs. So you don't want 1,000 test runs to execute as part of every continuous integration build. So things, for instance, practices or emerging practices like, for instance, test impact analysis or selective test case prioritization, those tremendously improve developer experience by shortening the feedback loop. Also, another interesting aspect that we have observed, especially as developers get dragged into resolving, let's say, production issues, you might want to start looking at posing a natural question. And this is the beauty of AI, isn't it? Which is you start to converse with your system in a very natural language style. So you might start off with a question like, why did my service break? Or more technical questions like, what recently changed between the last deployment versus now? What has changed in the last 24 hours? And that could be your starting point. And the system then responds with very pertinent and contextually relevant insights for you. And this helps with root cause analysis. If you now look at the next approach of uh, improving software delivery efficiency or using AI augmentation within DevOps, it's about how you can try to optimize the full SDLC. Now, here's where I think this is the first time we're very proud to look at all of the use cases that are possible here and today. So what you see on the slide now, this is not science fiction. All of the bullets that we have sort of shortlisted, we've identified here, they're either generally available as part of a DevOps platform, they're part of AI coding assistance, or they're at least in a published roadmap for given vendors. So I just want to confirm and validate that we've not just pulled these use cases out of thin air and want to claim that, okay, this is the art of the possible. So a lot of, in fact, almost all or all of the bullets that you see here are practices that you can implement here. So do go beyond just emphasizing on the create aspects of the SDLC. So you don't want to take a look at, for instance, how can you use AI augmentation during planning phase, during creation, during verification, right? Like we mentioned, another aspect of verification that we've not discussed so far, we talked about, let's say, on the quality aspects, AI augmented test generation, right? So there's lots of benefits around how can you augment the testing phase, whether it is at a very granular level, like I'll give you a couple of examples. Unit test generation, which developers tend to generally avoid, that's sort of the lowest hanging fruit for AI augmentation. In many cases now you're starting to see tools like you can provide natural language inputs or prompts, and then there are tools which will convert a natural language prompt to a Java unit test case, right? Or in any kind of programming language that you're using. Or you have tools where it takes an entire existing code base and automatically generates a lot of unit tests. The other aspect is test impact analysis. Like I mentioned, it's extremely important for us to shrink and selectively prioritize the number of tests, also the quality of tests that we run with every continuous integration build. In addition, verification also includes security automation, because if you think about it, security automation is it's it goes hand in hand with code completion, right? So if you're using AI augmentation for code completions, you do want to also augment your security automation, because you don't want one aspect of programming activities to be augmented with AI and leave your security automation to be an entirely manual exercise. I'll have a lot of I have a specific slide that talks about a cadence mismatch. But hold that thought for now. Also, if you're looking at the complete SDLC lifecycle, you're really looking at how can you augment other aspects. That is, on the ops side, very like one of the common questions we come across is, can we use change impact analysis? So the question often is, how can we predict if a given change is going to cause a failure in production? This is an extremely important question, and in fact this is something that AI augmentation holds a lot of promise. And the idea here is to use a multitude of factors. For instance, this is not just about focusing on code, but also the history of developers who have contributed to a given repository, right? Identifying, making sure that you triangulate different parameters, like do the developers who have just checked in code, what's the level of familiarity they had with the code base, or do you have new hires who've just contributed code to this change, right, to this change set? So which means there's a little higher element of risk when you have new hires who are less familiar with the code base. Or maybe the other element of risk here could be, are you introducing a change in a foundational library, as opposed to maybe just the UX layer, which just affects one aspect of your entire application. So there's different aspects of risk that we have to triangulate. Also, for instance, if you let's not discount the impact of AI augmentation on the monitoring and observability side, especially on the ops side, because the more you can use AI augmentation for automating incident response, the greater the customer satisfaction, because it dramatically reduces any kind of downtime. And it's in fact, I think, one of the more understated, underappreciated benefits of AI augmentation. Historically, we've given it a blanket name like AI ops, but we are starting to see more interesting use cases around, for instance, automated configuration of runtimes through autonomous workload optimization, or whether it is augmented FinOps. But overall, I hope you get inspired with the different use cases that are possible, not just in one phase, but across multiple phases of the SDLC. Here are a couple of very tangible vendors that we've pulled together that can help implement those practices that we just discussed. Everything from, let's say, planning, where you have some tools that can augment the planning phase, to obviously design to code, to coding assistance, to automated vulnerability remediation, to now autonomous workload optimization, automated incident response, augmented FinOps, which is all about cost optimization, and so on. Now, we love this quote from Sandhya Sridharan, who is the head of engineering platforms at JP Morgan Chase. And I couldn't have said this better, which is the rapid evolution of centralized platforms in every stage of the software development lifecycle is going to completely revolutionize software engineering. And so this reinforces the idea that if you want to truly benefit from the end-to-end implementation of AI, or you want to truly benefit from AI augmentation across the complete end-to-end life cycle, it's not helpful to think about applying AI to just one phase, because the real bottleneck or the, the real constraint can actually lie in other phases. Now, lastly, let's look at how can we optimize software delivery infrastructure. And if we think about software delivery infrastructure, it it revolves around these three attributes, right? So you're looking at reliability as one aspect of software delivery infrastructure. Reliability can take different forms. For instance, availability is a very classic example of this. Maybe reliability can take other aspects like latency is another element of reliability, but also the more emerging aspects of sustainability or very traditional aspects of cost optimization. But here's the key thing: we've not been able, from a technology standpoint, we've not been able to achieve trade-offs between these different optimizations, right? So, for instance, our focus has been taking a unidimensional approach, like I like to point out, which is in terms of, let's say, a lot of tools that we use currently, it's they focus more on let's improve reliability. But does improving reliability compromise maybe our cost obligations? Or, for instance, if we focus on sustainability, does it have maybe an adverse impact on reliability, right? So we've not been able, as an industry, been able to optimize or achieve trade-offs across all of these dimensions together. Now, you might wonder, is this really such a big deal? Is software delivery infrastructure so complex? And yes, it is. And to maybe oversimplify it is not helpful. So if you think about what makes software delivery infrastructure so complex, I've tried to distill it into these four dimensions, like you see here, right? One is, for instance, think of software delivery infrastructure as supporting multiple phases in the SDLC. So this can go all the way from planning to creation, verification, and to deployment. But the other dimensions are, now you take all those phases and apply them to multiple environments, both pre-production as well as production environments. And now you're slowly starting to get a sense of how the delivery infrastructure can become extremely complex. But let's not stop there. Now you got to think about delivery infrastructure across multiple layers of the topology, right? Everything from infrastructure that is compute, network, storage, to middleware, to databases, to APIs, and the UX layer. And you got to include elements like DNS, caching, servers, and so on. And don't forget, we got to do this for every application, right? It's not just about one application. And if you multiply all of these dimensions across in any typical large enterprise, you can see at least roughly, give or take, about 2000 plus applications, and you're seeing the enormity of the problem, right? And so one of the things that we normally look at now is, how can we use AI augmented DevOps to achieve a trade-off across these different dimensions of cost savings, reliability, and sustainability, and do so across the entire software delivery infrastructure landscape. What I've identified here and what you're seeing on this slide is looking at specific use cases, like, for instance, the very first use case. How can we use AI to predict demand and accurately auto scale infrastructure and literally optimize across all of these three dimensions, right? So if you sort of analyze each of these use cases, the benefits of AI augmentations can vary between these dimensions. And maybe what I would probably recommend to you is take a look at the top use case and the bottommost use case, which is about how can you use technologies like auto configuration of application runtimes, which gives you benefits across all of these three dimensions. Because we don't want to over index on one dimension at the cost of the other dimensions. Now, having looked at all of the benefits of AI augmentation, let's also be wary of pitfalls. I want to point out very quickly a couple of pitfalls. One is, what we've really seen is, as you start using AI augmentation to automate code generation or just in your development process, what you'll find is it exponentially increases the pace at which you can write code. But remember, the pace at which you can secure code does not increase at the same rate. It has a linear or at most a logarithmic scale of improvement. And so what this points out is a cadence mismatch. And this is an opportunity One, if you're a vendor, which is, this is an opportunity for you to think in terms of how can we provide auto remediation capabilities. But also, if you are an end user who's just developing code, you might want to start looking at, well, we can't just emphasize improving development velocity while we don't invest enough on our security automation capabilities. So remember that focusing on basic security hygiene, whether it is secrets scanning or whether it is SAST capabilities, those become even more important as you start to look at augmenting your development capabilities. And this is where I think the reason we want to come back to where platform engineering teams play a huge role is they will look at this from a systemic standpoint, right? They're not going to look at this as saying, okay, this is just for one team or one phase. The other aspect we've also come across, and I think this has been a huge revelation for us, is how can we reframe the return on investment of AI augmentation? Because most consumers, or in general, the software engineering teams, and even from, let's say, if you're a chief financial officer, you're looking at benefits in terms of time savings, faster coding, cost reduction. But all of this is to say that we are probably undermining the other aspects of the true value generation. So let's not forget what lies below the tip of the iceberg, right? So, which is, you might want to look at AI augmentation as not just improving developer productivity, but also looking at how can we improve developer experience, our ability to actually attract top developer talent, right? So these days, developers will go where they're able to do their best work. And so this leads us also to the other aspect of saying, how can we have our best developers go from just being productive to also being more creative? And so this is another implication of AI augmentation across your full SDLC. And lastly, I think what I'm fascinated about is try to think of AI augmentation. One of the pitfalls that often comes up is, are you really saving effort or are you shifting effort? And so this is a question we got to ask ourselves, which is, if you think about AI augmentation, well, we might shrink the time it takes to write new code, but ask yourself, are you moving that effort to now spending more time on debugging the code that you've written? Because you don't necessarily are paying attention to every line that's being generated. Or on the operations side, how much time are developers now taking to troubleshoot issues because they don't have intimate familiarity with all the code that's being generated? So remember also the other aspect around peer review. So if you look at the left and the right side of this graphic, you're seeing how the amount of time maybe it took for peer reviews before was much lesser, because we took a lot of time to write code, right? And everybody understood what's being written and probably took, they adhere to coding guidelines. And now maybe peer reviews take much longer. Well, of course, you could argue that AI augmentation or using AI can also automate peer reviews, but it doesn't obviate the need for human oversight, right? So bear in mind that it's not about shifting effort from one phase to another, but where you'll truly start to see benefits is if you start to save your efforts. And bottom line, let's remember that platform teams have a dual responsibility. It's not just about reducing undifferentiated work, it's also about how we can provide differentiated capabilities to multiple product teams across the complete software development lifecycle. So, with that, yes, I conclude my session here. I hope you found this helpful, and thanks for your attention.